Hello viewers, today we'll be treating rationalization of SURDS. Okay, listen. Whenever SURDS or roots are expressed as fraction, for instance, 2 over root 3, or I can have 7 root 5 all over root 2. Okay, something like this. So you can see that the surds or the roots are expressed as fraction. All right. Now, whenever surds or roots are expressed as fraction, and if the denominator of the fraction is a root, like this one has root, this one also has root, they are the denominators. If the denominator of the fraction is a root, then rationalization will take place. That is the only reason we will what? Rationalize. Alright, so what is rationalization? For instance, I have 2 over root 3, okay? And I want to rationalize. So what is rationalization? Rationalization is the process by which one uses the denominator with root to multiply the numerator and also the denominator. Look at it. Now, rationalization is when I use the denominator with the root. I gave a condition. The denominator has to be with root before you rationalize. So if you use this denominator with root to multiply the numerator and also the denominator, this process is called what? Rationalization. Okay, using the denominator with root to multiply the numerator and the denominator. All right, so what is the essence of rationalizing? And the essence of rationalizing is to ensure that the denominator is without a root. That is why we are rationalizing. Okay, the denominator here is with a root. So if we want to remove this root, then we have to rationalize. Are you getting it? So this is the process. Alright, so what do we do? Now we'll say 2 times root 3. 2 times root 3, 2 will multiply invisible 1 here because there's an invisible 1. I will not write 1. Okay, so that will be 2. Okay, and then the root 3 has no root to multiply here, so we'll also keep it there. Okay, root 3. Are you getting it? I said 2 times root 3. Number will multiply number, then roots will multiply root, but these two will multiply what? Invisible 1 that is here, which is 2. Okay, and then this one has no root, so this root 3 times invisible root here, okay, is still what? Or times 1 here is still what? Root 3. That is why you have what? 2 root 3. So 2 times root 3 is what? 2 root 3. You understand that? Okay, then all over root 3 times root 3. Root 3 times root 3 is what? 3. I told you before that when the roots are the same and you are multiplying, it's just the number, okay, in the root. So look at it. The answer is now 2 root 3 all over what? 3. And here the denominator is without root. And that is what we are looking for. Okay, it then means that we have rationalized the surd. Are you getting it? Or you can also say 2 over what? 3 root 3. Okay, it's same thing. Are you getting it? So let's look at the other one. The second one is 7 root 5 all over root 2. Okay, 7 root 5 all over root 2. How do we rationalize it? The denominator is with a root, so we use it to multiply the numerator and also what? The denominator. By doing that, the denominator will be without root. Okay, so let's do it. So multiply the numerator with what? Root 2, and the denominator with root 2 also. Are you getting it? So now we'll multiply 7 root 5 to what? Root 2, and root 2 times what? Root 2. Okay, so 7 root 5 times root 2. Here 7 will multiply invisible one here to be what? 7. Okay, and root 5 times root 2. Since the roots are not the same, it then means that they will give us a number in root. Root what? 10. Are you getting it? Root 5 times root 2 is what? Root 10. Okay, all right, all over root 2 times root 2 is what? 2. So you can see that the denominator is without root, and you have rationalized. Are you getting it? That is how we solve what? Rationalization. Again, if you have a question like this, say 3 root 2 all over 5 root 3. If you are asked to rationalize this, I told us that before you rationalize, then the denominator has to be with root. Okay, so if you are rationalizing this, okay, you know that we are going to use the denominator, okay, that is with root, to multiply the numerator and also the denominator. Okay, that is rationalization. So rationalizing this, we are going to say 3 root 2 over 5 root 3 times, we are using the 5 root 3 to multiply the numerator and also the denominator. Are you getting it? Alright, so we are going to use 3 root 2 to multiply 5 root 3. Okay, so 3 will multiply 5 because they are the numbers and number and number. 3 times what? 5 is what? 15, and root 2 times root 3 is what? Root 6. Okay, because the roots are not the same. So again, all over 5 times 5. 5 times 5 is what? 25. And multiplying the roots, root 3 times root 3 is what? 3. I told you when the roots are the same and you are multiplying, it is just the number in the root. So we are going to use the 3 to multiply 25. Are you getting it? Alright, so this will give us 15 root 6 all over 3 times 25 is 75. Okay, alright, we can also write it like this: 15 over what? 75, then root 6. So at this point, you check if the two numbers have a factor. Okay, for instance, the 15 can divide itself once. Okay, 15 can go to 75 5 times. Okay, so this will be 1 over 5, okay, root 6. Or better still, is it the same as what? 1 times root 6. You can write what? Root 6 all over 5. Okay, that is the answer. Are you getting it?